So we discussed the Bayes theorem on inverse probability. So the Bayes, where is it used? Right now, the same example we will take of that of having n bags. Okay, this is bag. All right. So I'll call this as bag A1, bag A2, and you have n bags, and they are different colored balls. Okay, let us say this has 3 red, 5 blue. This has 4 red, 4 blue, and this has 8 red and 3 blue, something like that. Okay, now one of the events, so we want an event B. Here we are talking the way the definition, if there are n mutually exclusive and exhaustive events A1 to AN, and the event B follows these. So let this event B be equal to the event of choosing a blue ball from any one of the bags. Okay. So then what we get is, so so probability of B is probability of choosing A1 and probability of choosing a blue ball from A1, then probability of A2, and probability of choosing the blue ball from the bag A2, so on, probability of choosing the nth bag, and probability of choosing the blue ball from the nth bag. So this is the theorem on total probability. This is total probability theorem. Now, what is the inverse probability? Now, inverse probability means, now let us say I choose the blue ball from any one of the bags and I just handed over the blue ball to you. All right. You do not know which is the bag from which I have chosen. Now you have to guess that, this has come from, you have to assign a probability of getting it from bag A2, let's say. Okay. So given that a blue ball is chosen and you do not know that from which bag it has been chosen, now if we have to go backward step and check which bag, so usually here, so I'll draw it like this. This is bag 1, bag A2, bag A1, bag A2, bag AN. So This is our first choice. First choice is between either choosing bag A1 or bag A2 or bag AN. Okay. After choosing that, then we choose the red ball. So from one of the bags, once we have chosen, okay, I should make with different colors, it will be easier. First I choose bag A and then I choose a red ball. Sorry, blue ball here. In our case, we are discussing blue ball, so I will stick to that. So first choice is between, I select the bag, and then from that bag, I select the blue ball. So it can so happen that it has come from bag A1 and I select a blue ball, or I choose bag A2 and I select a blue ball. Now, then I choose bag AN and select a blue ball. Now, this is the outcome that I've selected a blue ball. Now, let us say that this is not known to us. That which has been this is not known to us, that which bag has been chosen. So we know that this outcome has come. This is the outcome. Now, from now we have to do a reverse estimate of which bag was chosen. That is the inverse probability. You have to assign probabilities for the bags. So that is the inverse probability. I am showing now the reverse arrow. Reverse arrow indicating that given that blue ball has been chosen, given that blue ball has been chosen, what is the probability that it has come from a specific bag A1? So blue ball has chosen. What is the probability that it has come from a specific bag A1? Okay. So that is the reverse probability. So it is like this. So a specific bag AI, I can be anything. So now what I want to find out is, I want to find out probability of, probability of AI given that this event B has taken place. Probability that the ith bag was selected given that the blue ball has been chosen. So what is the probability, given that blue ball has been chosen, what is the probability that it was selected from bag AI? So now, according to the conditional probability theorem, this is probability of AI intersection BI upon probability of B. Now, probability of B from the total probability theorem is this. So this will be Now I will reverse the logic here. I will write this as, I can write this as probability of first choosing AI. This is from multiplication theorem. AI intersection B is probability of choosing the first bag and selecting blue ball from it. Okay. Probability divided by P of B. So this is P of AI into P of B given AI divided by P of B. What was P of B here? P of A1 into P of B given A1 plus P of A2 into P of B given A2, so on, plus, okay, we can include one P of AI term here, P of AI into P of B given AI, the last P of AN, P of B given AN. So this, so probability of AI given B, the reverse. First, see, this is two successive events, you can say. So this is the first event, E1, and this is the second event. Actually, they are compound because they both happen simultaneously. So here, the cause and the effect. So cause is happening first and then the effect. Now we have to find out, once we know the effect, we have to find what caused it. So this is the Bayesian theorem of probability. So this is the Bayes theorem, and we can simply write in short by mathematical notation. So given the event has taken place, what could be the cause? So P of AI given B probability is, see, you write the total probability. In the total probability, the term containing AI goes to the numerator divided by the total probability. That is your probability of Bayes. So P of AI into P of B given AI by sigma P of AI into P of B given AI, I equal to 1 to n. So this is the Bayes theorem of inverse probability. Okay. And this blue lines here indicate the inverse probability. Now, Bayes theorem is so much used. All of statistics, the craze for data science and statistics and machine learning that is there, that is dependent on probability and statistics. And these probabilities, especially Bayes theorem, is tremendously used. Okay. So let me open one Word file. Just a second. Now, I will tell you where Bayes theorem is used. Now, we come across this thing in word, right? Now, let us say I want to spell a word shoulder, and I spell. Now, when I right click for doing the spell correction, it shows options. How does it choose these options? Behind this program is the Bayes theorem that is working. So it is, this search engine is based on the Bayes theorem of probability. It is assigning probability. Now, this is like there may be many. Sometimes you get yes. Now, sometimes we get a lot of options like this. All right. So what this program decides is, okay, a person was trying to spell this. It doesn't match with the dictionary. Now, what is the near about words that he might be choosing? So we are typing, but the program is trying to guess that what is that we are trying to choose. So we use Bayes theorem to give ascertainment, and it assigns probabilities. Whichever is the highest probability, that will come on top. Whichever has the lowest probability, that comes at the bottom. So this is how Bayes is used. So let us take example, then it will be clear. Let us do this. A bag contains a bag A contains 2 white and 3 red balls, and bag B contains 4 white and 5 red balls. One ball is drawn at random from one of the bags. And is found to be red. What is the probability that A bit it was chosen from bag A? What is the probability that it was chosen from bag B? So 2, we want to see this. So this problem will clarify. Okay, let's look at the solution. Okay, so let A be event of choosing bag A to withdraw a ball, to draw a ball, and B be the event of choosing bag B to draw a ball, and let E be the event of choosing a red ball. Okay, let E be the event of choosing a red ball. So now event E is following either A or B. And if event E has occurred, it means that A or B must have occurred. So we have to apply the total probability theorem. So therefore, probability of E, that means probability that a red ball is chosen, is probability of selecting bag A and probability of selecting red ball from bag A plus probability of selecting bag B multiplied by probability of selecting red ball from bag B. This is the first step. If you want to solve base theorem problems correctly, the total probability theorem has to be properly written. Okay. Now, let us calculate this one. Now, between bag A and bag B, there doesn't seem to be a big difference. There is nothing specified that there is this much probability of choosing bag A and this much probability of choosing bag B. Okay. Now, bag A contained 2 white and 3 red balls. Bag B contained 4 white and 5 red balls. Okay. Now, so P of A, probability of choosing bag A, because they are bag A and bag B, both are equally likely. So probabilities will be equal. Probability of bag A and probability of selecting bag B, both will be half. Sometimes if you are, sometimes it may so happen in a problem that, you can prefer bag A twice as compared to bag B. That means this will be 2 by 3, this will be 1 by 3 probability, if it is given like that. But in this question, nothing has been given. So we have to take this as an equally likely matter. Now, given that first bag has been chosen, what is the probability of selecting white ball from it? So given that bag A is chosen, then there are 5 probability of choosing red ball from it. Sorry. So there are 5 balls. We have to choose the red ball. So the number of ways of choosing the red ball is 3. 3C1. Number of total number of cases is total number of balls are 5. So out of the one of the 5 balls, we are selecting a red ball. So the probability is 3 upon 5. Probability is 3 upon 5. Similarly, probability of choosing red ball from bag B. There are total 9 balls. So number of ways of selecting any one of the ball is 9C1. And there are 5 red balls. So number of ways of selecting red ball is 5C1. So 5 upon 9. So probability of E given A and probability of E given B is this. So now we'll do what is probability of E. Probability of E is, so the same thing, probability of A into probability of E given A plus probability of B into probability of E given B. This is half into 3/5 plus half into 5/9. Okay, we can evaluate this or leave it at this juncture. We will have to actually this will be 10 and 8, so 90 is the common multiple, and then this is 3 into 9. Hmm. 3 into 9 plus 5 into 5. So 25 plus 27, that is 52 upon 90. Okay. Now, I want to find the first question. Now, given that red ball has been selected, what is the probability that it came from bag A? So this is what we are finding. So probability of A, given that this event E has occurred, is probability of A intersection E by probability of E. So probability of this event E. So this is probability that bag A has been selected and red ball has been selected. So that is probability of A into probability of E given A divided by probability of E. So probability of A is this one. This is half into 3 upon 5 by 52 upon 90. So this is 3 by 10 into 90 by 52. So this is 27 by 52. So this is 27 by 52. That is the probability that it has come from bag A. Now, the probability that red ball came from bag B is probability of B, given that red ball has been chosen, which is probability of B intersection E by probability of E. So this is probability of B into probability of E given B. So this is 1 by 2 into 5 by 9 52 by 90. So 5 by 18 into 90 by 52. 18 5s 90. So we get this as 25 upon 52. So the first bit, answer for the first bit is 27 upon 52. The second bit is 25 upon 52. Clear? Clear? Do you have any questions here? You can ask right now. Any step you didn't follow? Because this is the basic. After that, we do little more difficult problems. Problems is difficult not because of applying Bayes theorem. If the concept is clear, it may get difficult in terms of calculation. As far as concept wise, it is very, very easy once you get the concept right. All right, we'll do more problems. Okay, the first part I did already. Okay, this is a famous problem, very commonly asked in probability. So question 2. A man is known to speak the truth 3 out of 4 times. Okay. He throws a die and reports that it is 6. Find the probability that it is actually a 6. So he has reported. Now we have to check whether that has actually taken place. So let's do that. So first, let us write the events. Let T be the event. Generally, we should, I choose, you can always choose different letters, but I choose relating to the terms that we are using in the problem. So I choose I choose here T as the event of the man speaking truth. And F, the event of the man speaking lies, untruth, or falsity, false. Okay, I'll speak truth. English. Event of the man, the event that the man speaks truth. Event that the man speaks false. Okay. Now The experiment is rolling of a die. Okay. Now let's say E is the event that the number 6 appears in the rolling of a die. So we can find the probabilities now. Now, given that probability of man speaking truth is 3 out of 4, then what is the probability of his speaking false? So this is nothing but it is truth bar. Okay, because there are only 2 events. If there was more than 2 events, we can write different letters, but this is like either he speaks truth or he speaks false. There is not in between. So this F I'm writing as T bar. He is speaking false. Now probability of event E occurring is 1 upon 6. There are 6 options and number 6 appears one time. And probability of E not occurring is 5 by 6. Oh, okay. I should not. I'll replace this event slightly differently. Okay. Now let me write this as let E be the event that the number 6 is reported. Okay, because that is reported, it may be true or it may be false. We know probability of getting 6, so it is like this. So 6 is reported. It might be that it is probability that he is speaking truth and probability that he is reporting that it is 6 given that he is speaking truth, plus probability that he is not speaking truth and probability that he has reported 6 when he is not speaking truth. Okay. Now, probability of his speaking truth is 3 by 4 into this is probability that it was actually a 6. This is same as he is speaking truth and he has reported that it is 6. That means probability of number 6 appearing. Now he speaks false, but he is reporting 6. That means probability of number 6 not appearing. Probability of number 6 appearing, this is he is speaking truth. This is what it is. He's reporting that it's a 6. Now he speaks truth and he reports that it is 6, and he speaks for lies and he reports that it is 6. So this probability that actually a number 6 appears is 1 upon 6. And that he speaks lies that it is 6, but actually it is not. That means it can be any number 1, 2, 3, 4, 5. So it is 5 out of 6. Okay. So this is a very good problem to understand. So this is P of E. So this is 8 upon 24. 5 plus 3, 8 upon 24. So this is 1 upon 3. Now we want to find out the probability that it's actually a 6. Now given that he reports a 6, given that the man reports a 6, okay, that 6 has come, that is event E. Given that event E has taken place, he is reporting a 6. Now, probability that it is actually a 6 is the event that he speaks truth. So this is the event that he speaks truth. So the event is T. So what is the probability that he is speaking truth given that he has reported a 6? This is the inverse probability we want. This is probability of T given E by probability of E, which is probability that he speaks truth and he reports a 6 given by the total probability. So it is just this 3 by 4 into 1 by 6 upon. We can keep as it 8 by 24. 8 by 24. 6 fours, 6 fours cancels. You get 3 upon 8. So the required answer is 3 upon 8. Is this clear? No answers? No response? Let us do 2 more problems on this. Others you can try. So question 3, I want you all to try this. A person goes to office with just a sec. This is either. This is E. A person goes to office either by car, scooter, bus, or train. Probability of which being 1 by 7, 3 by 7, 2 by 7, 1 by 7. By car, 1 by 7. By scooter, he goes to office, that is 3 by 7. He uses a bus, 2 by 7. And he goes by train, 1 by 7. Probability that he reaches office late if he takes car, scooter, bus, or train. Given that he takes a car, he gets late is 2 by 9. And given that he goes by scooter, he gets late is 1 by 9. Given that he goes by bus, he gets late is 4 by 9. And if he goes by train, 1 by 9. Given that he reached the office in time, what is the probability that he traveled by car? So this is the inverse probability. So I'll give you a few minutes. You please attempt. Do a calculation. You do rough and fast calculation. Don't have to write detailed descriptions of it. Okay, good. Some answers have come. One answer is correct. Okay, now let us do this. So let C be equal to the event of traveling by car. Then S be the event of traveling by scooter. Then B be the event of traveling by bus. And T be the event of traveling by train. Now, let E be the event that he reached office on time. Now, given that he has reached late, the probabilities given are, so E bar will be the event that he reaches office late. So here, let us list the probabilities now. Now, probability of going by car is 1/7. Probability of going by scooter is 3/7 given. Probability of going by bus is 2/7. And probability of going by train is 1/7. Now, we want that. Now, if what is the probability that he goes late? He reaches late, given that he has traveled by car. It is 2/9. Probability that he reaches late given going by scooter is 1/9, 2/9, 1/9. Probability of his becoming late going by bus is 4/9. And probability of his becoming late going by train is 1/9. So, but what do we want? We want the event of his reaching on time. This is important. So, therefore, probability that he reaches on time given he has gone by car will be 1 minus probability that he reaches late given that he has gone by car. So it's a complementary event. Going on time, reaching late. So this is 1 minus 2/9. So 7/9. Probability of E given S similarly is 1 minus here 1/9, which is 8/9. And probability of his going on time by bus is 1 minus 4/9, which is 5/9. By train is 8/9. So the total probability of his reaching on time is going by car and reaching on time by car, going by scooter and reaching on time by scooter, going by bus and reaching on time by bus, and going by train and reaching on time by train. So this is given the probabilities 1 by 7, 3 by 7, 2 by 7, 1 by 7. 1 by 7, 3 by 7, 2 by 7, 1 by 7. So now we just calculated these probabilities here. 7 by 9 is E upon S is 8 by 9. E upon B is 5 by 9. This is 8 by 9. So we get 7 plus 8 3 is 24 plus 10 plus 8. So 24 plus 8, 32. 32 plus 10, 42. 42 plus 7 is 49. 49 upon 63. Or divide by 7, 7 by 9 we get. Okay. Now, we want, given that this has occurred, what is the probability that he traveled by car? What is the probability that he traveled by car? That means we want this. There are these possibilities: car, bus, car, scooter, bus, and train. But we want this probability. So, probability of his using a car by base probability of his using a car, given that he has reached on time, is probability of his reaching on time by car, that is probability of selecting a car by into probability of his reaching on time by car divided by the total probability of his reaching on time. So this is 1 upon 7 into 7 upon 9 by 49 upon 63. So it is 7 upon 49, which is 1 upon 7. So in fact, for showing you, I am writing this, all this much detail. But if I have to solve for the objective, I will just write this much for the objective, because in my mind I have made calculations. So we just need to write this, and then this, the first term divided by the total. If we do, we get the base probability result. Okay. So 1 upon 7 is the probability. One more problem. This is also a good one. So I'll again give you time to do this. Now there's a multiple choice in an exam. An examinee, a student, either guesses or copies or knows the answer. So guesses, copies, or knows the answer. Three possibilities. To a multiple choice question with four choices, more than one correct. So there is multiple choice with four choices, of which more than one can be correct. The probability that he makes a guess is 1 by 3. Probability that he copies the answer is 1 by 6. And probability that he knows the answer is not given. Okay, that is not given. So the probability that his answer is correct, given that he has copied, is 1 by 8. Find the probability that he knew the answer to the question, given that he has answered correctly. So given that he answers correctly, of course, we are rolling out that option that he has left this question unattempted. So that is not there. So now please work out. I'll give you a few minutes. Okay, no answers so far. I'll give you 1 more minute or 2 more minutes. You please try. Sorry. Let G be the event that he guesses, and C be the event that he copies. And K be the event that he knows the answer. And E be the event that he answers correctly. Now let us do the probability. So now it is given that if he guesses if he makes a guess, the probability is, so P of guessing, probability of guessing is 1/3. Probability of copying is 1/6. So the probability of knowing, given that there are only 3 options, will be 1 minus probability of guessing minus probability of, because they are exclusive events. They are mutually exclusive events. If he guesses, he will not copy. If he copies, he will not know the answer. So these are mutually exclusive events. So the union will be 1. P of, so if he is guessing 1/3, if he is copying 1/6, then probability that he knows the answer is 1 minus 1/3 minus 1/6. So this is 18 minus 6 minus 3/18, which is 9/18. So half. The probability that he knows the answer is 1/2. Okay. So this was the hidden part of the question. Okay, it was not directly given. Now, what are the total number of ways in which the MCQ can be answered? There are, 4 options and any one of them can be correct. So let us calculate that. A, B, C, D. Now a person may select option A or not select option A in 2 ways. He may select option B or not select option B in 2 ways. He may select option C or not select 2 ways. Option D or not choose option D in 2 ways. So total number is 2 raised to the power 4. However, there will be one combination in which he has neither selected A nor B nor C nor D, but that we are omitting. So that we have to separate out. So this is 2 power 4 minus 1, that is 15 ways one can answer this question. So now comes this. So probability of his answering correctly, given that he guesses. So when he guesses, he has 15 options, of which one only will be correct. So his probability that he gives a correct answer, this is probability that he answers correctly by guessing. So this is, he has 15 options. Any one of the options he can choose. So that is 1 upon 15. Now, probability that he answers correctly by copying. Okay, that he is given already. Probability that his answer is correct given that he is copied. This is given to us. This is 1 by 8. Probability that he answers correctly by copying. So this is a given data, given in the question. Okay. Now probability that he answers correctly given that he knows. Suppose you know the answer. If you know the answer, what is the probability of marking it correct? It will be 1. It will be 1 because there's only one choice that you will choose, 100%. So this is the critical point of this question. Okay. So it will be 1. So now let us make the total probability. So probability that he marks correct is probability of guessing and that he marks correct. Then probability that he copies and that he marks correct. And probability that he knows and he marks the correct option. So this is the total probability. This is 1 by 3 times 1 by 15 plus 1 by 6 times 1 by 8 given plus probability knows we calculated it to be half here and he answers it correctly is 1. So we get this is 1 by 45 plus 1 by 48 plus 1 by 2. Okay, we can make this calculation. We can try to make this calculation. The answer here is 391 by 720. 720 will be the common multiple. You can check that. Now, the required probability is probability that he knew the answer to the question given that he is correct. So required probability is probability that he knows given that he has marked correctly. So this is this term by the total. So this is half into 1 by 391 by 720. So this becomes 360 by 391. This is the answer. This is the answer. Okay. So I leave here. Tomorrow, important, I'll stop for today. Tomorrow, very, very important. I will give at least, I'll make you solve at least 15 questions on probability, including Bayes theorem. Okay. So please go through all the basics and come. All previous years GATE question papers, questions we will solve tomorrow. So I'll stop now.